Now, when working with return values, no matter if it's one or multiple return values, you can use a little shortcut in Go, which I only recommend for usage in simple short functions, since it can make your functions a bit harder to read if they get very complex. You can name your return values. And at the moment, we're not doing that. In both functions where we have a return values, we just define the type here and then we return values like this. And that's the default case, which I recommend for most functions. But for simple functions, we could also work with named return values. To do that, we have to wrap our return types into parentheses, even if it's just one. And now we can use any name of our choice for that return value. For example, sum. Now that creates a brand new variable which is available inside of this function, which is declared right from the start and which is initialized to the null value of that type. In case of an integer, sum is initialized to the number 0. And then here in the function, we could use that variable, which is now available, to store that result, for example. Now here I don't use $=, but just $, because the variable already exists. As I just mentioned, it's created automatically by Go. So I just assign a new value to it, effectively overriding its null value, the 0 value, and then that's the new value stored in sum. And now we don't even have to return sum, though we can do that as well, but it is enough to just call return, and Go will then automatically return the variables defined here in that return list. So it will return sum here. Hence, if I save that all, and I now run this again, this still works just fine as it did before, but now with that slightly changed syntax using these named return values. And we can do the same if we have multiple return values. For example, here we could use R1 for the first random number and R2 for the second random number. And then here we just set new values to these variables. Hence we have to remove the colons because the variables already exist. And then just calling return is enough. And here this certainly saved us a bit of code. It's now shorter and maybe a bit more readable. So in short, simple functions, you might be able to simplify them by using named return values. In very long, complex functions, where you then maybe also introduce other variables throughout the function which will not be returned, it can quickly get confusing if you use named return variables and this return statement, which doesn't directly clarify what it returns. You then always have to have a look at this list to understand what's returned. So it's a trade-off, but it is a feature worth knowing since you will see it in other Go examples in the built-in Go packages and also from time to time throughout this course, like with these examples here. And that's it for functions. It is a rather straightforward feature, nonetheless a key feature which you'll use all the time to split your code into reusable code blocks, which you then can execute when you need to execute some code, potentially also multiple times. You can call every function more than once if you need to. And you'll learn about all these key features that make up functions. How you generally define them with the func keyword, that the name should describe what the function does, with exception of the main function, which is a special function, that you can but don't have to take input parameters, as many as you need, separated by commas, where you give them any names you want and define the value types they will be of, and that you can return values, but you don't have to do it. If you return values, you have to define the type right after the function name and parameter list. And you can optionally also use these named return values I introduced in the last lecture. You can also return multiple values in one function, in one and the same line. And you can then, of course, also store these multiple values in variables and then do with them whatever you need to do. These are functions. And now to practice them a bit more, we'll go back to the body mass calculator and see how we can improve our code there by using functions, more custom functions. We learned about functions. Now it's time to again apply what we learned. And for this, we'll revisit this BMI calculator we worked on earlier in this course, and we'll again apply what we learned to break up the code we have in this BMI calculator and split it into multiple functions. So that in this module, we do practice how we can write custom functions by splitting up that big main function which we got at the moment. And whilst doing that, we'll also see an example for how functions help us reuse code and why we use functions in the first place. Now for that, we'll continue working on that BMI calculator code we worked on before in this course. And in case you skipped that module or you don't have the code at hand right now, attached you find my code snapshot with that project as we left it. And of course, I want to say it right away, this project could stay the way it is. It works just fine, but of course we have a rather big main function, though of course it depends on how you define big. But this main function does multiple things. And as a general rule of thumb, you want to try to write functions that only do one thing each. I do have a complete course about writing clean code, which applies to basically all programming languages, and I do talk about that there as well. And this function, this main function at the moment does not do one thing, but it does all the things we do in this application overall. It prints some information here, then it gathers the weight and the height inputs, it does conversions, or it cleans the input and then does conversions, and then it does the actual BMI calculation. And therefore here we can certainly split up that function into multiple smaller functions to split that workload. Now, definitely feel free to try doing this on your own first. Come up with a couple of functions you could write on your own, and then move the different functionality into those different functions and make sure you glue them together in that main function again then, possibly using parameters and return values where needed. You can even try to split your custom functions across multiple packages, but that's totally optional. Now, in the next lectures, we're going to split that up into multiple functions together, and then you can always compare your solution and your approach to mine to see how I solved this. Now, to split that up into multiple functions, let's first of all identify the different workloads we have here to find out what we might want to split up. And we could, for example, put this general information into one function that we call. Then we could put the logic for fetching weight and height into separate functions. We could even put that logic for reading user input in general into a custom function. And we might want to put that cleaning and parsing step into a separate function. And then, of course, we also might want to put this BMI calculation into a separate function, so that if the formula would change, which it of course won't, but if it would change, or if we would change the code somehow, and we would be calculating the BMI in different places of our application, we only have to change it once, instead of having to search through all our code base and changing the formula in different places. And then last but not least, of course, this output here could also go into a separate function. And therefore, I'll start here at the very top with outputting that information. For that, I'll add a brand new function. And since we already have a separate package called info, I'll put that function into that package. Not something which you have to do, but something which might make sense given the fact that we have that package already. So in this info.go file, I'll add a new function, which I will name print welcome with a capital P at the beginning. because this function should be callable from outside this package, so from inside other packages that import this package. And it won't take any parameters, it doesn't need any input, and it also won't return anything, but instead, inside of this function, I just wanna use the format package. Hence, we have to import format here in this info.go file, and then here execute the println function, which is built into that format package, and print the main title, which we now actually can convert back to a lowercase m at the beginning, since we only use it inside of this info package. We'll not use it in other files anymore in the near future. So here I'll refer to main title with a lowercase m. And then I'll also print my separator, which now also can be transformed to start with a lowercase s, since I'll only use it here in this package. I'll keep wait prompt and hide prompt the way they are, since at the moment they are getting used outside of this package as well, and hence I only added this function and changed these two constants. Now back in bmi.go, instead of having these two lines of code here, we can use our info package, which we are already importing here, to call that print welcome function like that. So we still call a function like this if it's from another package. The only difference is that we refer to that package and then use this dot notation to access the function in that package which we want to execute. And that's step number 1. That's my first custom function using what we learned before.